Dear friends, good morning. Last couple of lectures we have learned about how to do the simulation of half wave converter and full wave converter and semi converter. We understood that difference of load effect, resistive load, inductive load, and how will be the continuous conduction and how one can understand the discontinuous conduction. Also, we have learned three-phase full converter and semi-converter as well. Then apart from that, we have understood that if the semi-converter is used, there is no negative swing in the voltage, so average output voltage will be increased. These are all those things we have learned through the simulation. So in this lecture, I am going to explain what is the importance of capacitor in this three-phase and full wave converter, and by through the simulation, if you want to connect this three-phase or single-phase full converter or whatever, maybe full semi-converter to any DC motor, before that DC motor will receive only the constant DC voltage. How one can make it this constant DC voltage? All those things we are going to learn today. So now in this lecture, I am not going to show any design parameters, how to design the capacitor. These are all the basic things which is available already in the many power electronics books. So only I already selected some of the capacitor. Just I will show and connect it how the capacitor effect is changing the output voltage of the full converter, three-phase and single-phase converter. I am going to explain. So let me share my presentation now. So this is what we have already done, this single phase full converter. This is I have connected only resistive load. Assume that we have not I have not connected any capacitor. This is open circuit, but this waveforms I am going to run for 0.08 seconds. That means 4 cycles. See here, this output voltage have ripples are there. Output voltage will be have ripple. Then moreover discontinuity will be there. So if you connect as such in this DC motor, it will affect the speed of the motor. There is having some fluctuation in the speed as well as the voltage is having some variation. So moreover, it is not good for DC motor control also. So hence, what I am going to do now, I am connecting this connecting one capacitor of 1 microfarad. In this 1 microfarad, if I connect it here, it will not show much improvement in this output voltage. So let me increase this capacitor value. Instead of 1 e power minus 3, 1 e power minus 3 instead of minus 6. See now this voltage now some continuous conduction is happening. This means capacitor, whenever the discontinuation will happen, capacitor will discharge, so that we are having some continuity in this current, continuities in this voltage. So if I keep on increase this capacitor for 1 farad, we can see here that again this good improvement in this output voltage. But if you run the simulation for 1 second, we can see some signature of ripples in this DC output voltage. See here some signature in this DC output voltage. So ripple voltage is varying between 310 to 295, something like that. So if some percentage of ripples are there, if you keep on increase this capacitance 2, then 3, then 5, then if you make it for 10 farad, if you see this capacitor, we have this output voltage is having clear cut DC voltage. It will gradually increase and settle down to maximum output voltage 300. So that we are using this capacitor. In this capacitor, the frequency of ripples will be 4 times the supply frequency. It will be 4 times the frequency will come. For example, if you make it this 1 e power, please remember that now that we have increased this capacitor to 10 farad. So we are getting the smooth output voltage. Now if you reduce it again to open circuit on 1 e power minus -6, you can get output voltage again, the ripples in this output voltage. So let me reduce this simulation time for 4 cycles so that you can come to know this capacitor effect, so output voltage effect. So this is very clearly giving this idea for single phase full converter. One cycle itself, we have two frequencies. One ripples are there, two ripples frequencies are there, so that we are going to ripple frequencies, we are going to reduce it. So ripples are also reducing as long as we are increasing this capacitor. So similarly, if you take this three-phase full converter, previously we have given this 10 farad. Now I am going to start from the starting, that now open voltage. So if you run the simulation for 0.08 seconds, means 4 cycles. See here, the ripples in this output voltage will be for one cycle. For example, one cycle means 0.02 to 0.04. One cycle. We can have ripples 1, 2, 3, 4, 5, 6 ripples are there. Six pulses are there. So we were based on that, one can design the capacitor. Other cases, if you connect this capacitor and make it 5 micro, instead of capacitor 1 e power -6, if we make it 5 farad, we can have if you connect this to run the simulation, we can have this output voltage of let me check, this output voltage of 5 farad, so that we can have this output voltage is sorry, this is a gate pulse. Output voltage will be increasing more. Output voltage is increasing. If you run the simulation for 1 second, we will come to know that output voltage is smooth. Output voltage is smooth. Moreover, higher value. This will conclude that for single phase full converter we have high capacitor value, but this three-phase full converter we have less capacitor value. So this is the conclusion behind. The reason is ripple frequency is 6 times. We can immediately capacitor charging and discharging will take place fast in this case of 3-phase. At the same time, single phase only 2 cycles. That is why we need more capacitor. In this case, we need less capacitor. With this, I would like to conclude for today's lecture. This simulation, which will help us to design the capacitor value. For 3-phase full converter, we need less capacitor, and filter capacitor, and the single phase full converter, we need a high value of capacitor. Wish you all the best. If you have any doubts and clarification, kindly message on it. Use the comment box. Wish you all the best. Thank you.